Hey friends, this is J Hook here. We're gonna hook around here with some quantum singularity action. Generally, I don't mess around with black holes, but you know, um, they're dangerous. You fall in, you get crushed. It's not something I want to do on the weekend or on a weekday. But what with all this madness with us taking pictures of black holes and quantum singularities, or well, they're the same thing anyway, figured I'd do a little tutorial on this little bad boy right here because it was a request as well. So we're all into the singularity today. Hey, how you doing, singularity? Being all singular, tiny little point. Okay, so all sorts of contraptions needed to do this safely. You basically need a lot of heat dissipation. It's going to produce a lot of heat. A ton of heat. A lot of heat. And this is nothing compared to, like, say if we had, like, antimatter going on here as well, but whatever. So we overcompensate with, like, 120 gigawatts worth of heating. So we've got a lot of scaling going on. I highly recommend using scaling when using anything with the Interstellar Extended mod because you just have to. It's necessary to fine-tune these bad boys to be at peak efficiency. So scale your stuff. So we got like a 7 meter and like an 825 and then like a 9 and then a 10. These ratios are completely arbitrary. I just wanted it to kind of zoom in, but I'm not that great at getting it to go all smooth and stuff, so whatever. It's 120 gigawatts of heat dissipation. It should be enough. Additionally, when you're running the Quantum Singularity reactor, this little bad boy right here, it eats, hydrogen. Small, teeny tiny particles, hydrogen, helium. You're going to get antimatter in the process, though, positrons and antiprotons. So why not store them, right? Yeah, so go ahead and throw, some storage for the positrons and antiprotons, and a little bit of extra liquid hydrogen in a refrigerator unit. Down here we've got the tri-alpha. That's going to charge and ignite the singularity. You need a lot of power. I think it's something like 12.8 gigawatts of electricity of power in order to jumpstart this bad boy. So put yourself a great big ol' 6.2 meter scaled up and fine-tuned to get it just in that sweet spot, because we're going to use it to ignite this thing and then it's pretty much done. But if we wanted to, we could have it running on low power to do some other stuff in order to produce helium for the other side of what we need. So we got plenty of hydrogen and a way to produce helium. We could also just put this thing in orbit around, say, a gas giant. And it's got a refrigerator unit, because I love these things. These things are life. Orbit a planet with an atmosphere, put a refrigerator unit and some air scoops, and you've got free fusion materials, which is what the future's all about. Alright, so a little bit of attitude control, so this thing can hold itself in place. Obviously future generations that are building these things are going to use things like quantum locking, similar to quantum levitation, except for instead of levitating, you're locking. You can look it up on YouTube, it's really rad. But they would use that to hold these suckers in place, instead of like fancy struts and whatnot, which is why it looks so ridiculous. What are you going to do with all this power once you get this black hole started? Well, probably beam it somewhere else that doesn't need to have a 273,000 kilogram object producing power for it. You just beam it on over. So yeah, we're going to do extreme ultraviolet. We're going to see how well we do beaming this stuff through vacuum. Make sure that your transceiver is also set to the same wavelength. And just for fun, we've put a Daedalus on there because this thing is just too cool for school. I'd have to say it's pretty superior to most other engines, except it can't be used in an atmosphere, which is where it has you know, it doesn't stand up to the Z pinch in that the Z pinch can be used in atmosphere, but the Daedalus makes up for that by being extremely efficient and pretty powerful for that efficiency once you have it fully upgraded. When you first unlock it in like career mode, it's poop. It's poo-poo. You don't want it. But unlock some technologies, and this sucker is look at that ISP. That is ridiculous for 3,000 kilonewtons. A little bit, it's absurd, and it uses fusion pellets. So once again, a refrigerator and a gas giant, and you refuel. It's no problems. So the Daedalus is really, really cool, just like the Bussard engine that is similar. Where's that at? Where are you at, Bussard? There it is. The Bussard's just, it's heavier and not as powerful, still extremely efficient, and has a neat little additional type of paint job on it. Let's see if we can, yeah, see? Pretty neat. It runs on hydrogen, so potentially, you know, we could just use the same fuel for the reactor. Again, refuel around gas giants. Seeing a theme here? Refrigerator units and gas giants and fusion technologies. That's all you need. Simple, right? No big deals. Anyway, so obviously I'm not going to launch this thing with a rocket into space. Ideally, you would construct a object such as this in orbit with much more sensible engineering qualities, such as like balance and, you know, structural integrity and whatnot. Like, this thing is absurd. But it's just a proof of concept, so we're just going to see exactly how, you know, the singularity thingy stacks up. So if you look at it in comparison, I still think this is kind of modest for heat dissipation for a tiny, tiny little black hole, because I think you'd need like a city block worth of heat dissipation or something. I don't know, maybe that is a city block. Who knows? Alright, so this thing, obviously we're just going to cheat it into space so that we can turn it on. Alright, so we're in space. Yay. I gotta say, looks pretty neat. All in all, not too shabby looking. Let's see if we can get a good view. Not too shabby. Okay, we don't need that anymore. Okay. So, let's see what we're producing here. Let's open up some of our instruments. Put that one there. Put this one there. Let's see, we need some reactor control windows. We'll put the singularity on the left. We will put the tri-alpha on the right. Now we have used up all of our screen real estate. We should be in business. Okay. You guys ready for this? So, we've got 24 gigawatts at our disposal. We need about 13 to turn this sucker on. So let's turn it on. Okay. Activate. It will start charging. It's like your fusion hoodookie is not enough. Get good. But we are charging. We are generating an absurd amount of waste heat. Wait for it, wait for it. There it goes. We are online. Oh, one thing to remember with these umbrella radiators. See how this thing looks like it's about to turn white hot and explode? Well, here's the thing. They actually don't start deployed for whatever reason. So go ahead and make sure to click on that deploy once you're out here, and look at the magic happen. This right here messed me up for a little while, and then I realized, oh, you got to actually deploy them. And then your waste heat starts going down to reasonable levels while you are controlling a quantum singularity out here in orbit, producing absurd amounts of power. Look at this. We got 83.9 gigawatts of power, and we are constantly producing 60. Our tri-alpha has turned itself off. It's like, I'm out. I don't need to be on anymore. everything's fine. For whatever reason, I think if I produced less heat, like if I actually had this thing cooled more, I might get more juice out of this thing. But for what it's at right now, I can show you something. See this here dish transceiver? Let's clear some of this out because we don't need any of that anymore. We're online and we are stable. Okay, let's activate the transmitter at full power. It is pumping out a maximum of 30 gigawatts. It can't pump out more than that. You can turn the transmission strength down if you would like, but screw it. Leave it at full power. We are still not even using what we are producing, so we're not actually producing more heat. We're actually not able to dissipate as much electricity as we're producing. So we are going to be pumping out 30 gigawatts on the, what is this, far extreme ultraviolet spectrum, outer space, with our big old rectenna, and it appears we can do so for about 30 years. 30 years. This thing will just stay on and might eventually overheat. Maybe we could turn it down at some point. But in theory, for 30 years, this thing will zap, you know, juice out into space. It's kind of cool. Let's see how we're doing on antimatter production. Oh, look at that. A lot. A friggin' lot. It's 51 milligrams there. And there. And we can just look over here. Where are we at? Positrons and antiprotons are just filling up. We've been up here for 4 minutes and 20 seconds. And we have more antimatter than we know what to do with. Thanks. Appreciate you. That's cool. Okay, so let's take a look at this engine here. Let's turn our transceiver off, or our transmitter off for just a second. And let's see what kind of thrust we get out of this here Daedalus engine. This thing's heavy, remember. It weighs a lot. What is that? 273. 273 metric tons. Because it's absurd. It's like ridiculously absurd. Like, what is this thing? Put that one over here. Okay, as you can see down here, this is not a joke. It says we have 23,253 meters per second of delta V using fusion pellets, using nothing but fusion pellets and the, 84 friggin' gigawatts of electricity that we are able to produce. So you turn this on, and you produce 3,000 kilonewtons of thrust. Gets us to about a G. So, decent thrust-weight ratio. Let's see here. Staying relatively low on the waste heat. Alright, so this thing's on, and it is increasing our orbit pretty steadily. It's a little slow. I mean, it's not like the fastest, but I mean, this thing does weigh 270 tons, and we are pushing it through space as if it were just a vaguely powered rocket. We're going to miss the moon entirely. There's really no point in doing this except to put us in a bigger orbit. But as you can see, the Daedalus engine loves electricity. You give it, how much does it want? 100 megawatts. It's very friendly. You don't have to actually power it a whole lot. This is actually not true with the Bussard engine. That one, loves electricity. The Daedalus is very, very power efficient. You don't need all of this to power that. You can power this thing with something teeny tiny. You can also use this to move something ginormous for very cheap. As you can see, as I've been talking, we're going to go ahead and escape the system. And we could potentially put this sucker down in low orbit around Eve or something. I don't know why we would want to do that, though. But it's just a proof of concept. We could also just turn this thing around. And not go to Eve. So can do that, and then I can show you what you could potentially do with a giant orbital singularity producing electricity for 30 frickin' years at ridiculous amounts. I mean, I suppose you could put more or a bigger transmitter on here. All right, let's slow our roll here so we don't fly off of this base. Since we have so much delta V, I mean, a silly maneuver such as what we are doing right now, it was no big deal. Really, it's no big deal. There we go. Okay, so that's that. Power plant, produce power for frickin' ever, and yeah, put it seriously anywhere you would like. Pretty simple, right? Not too much going on with this thing. Efficiency starts to go back up as you cool. As you can see, as it's just sitting here. You know, it's cooking. It's using all that electricity. You might ask yourself for what, but it really just can't stop. It's on fire. So yeah, once you get one of these things, treat it well. Use it for all kinds of cool science stuff. What I would probably do, if I can find Barnes, yes. Oh, you know what? I forgot to turn on the transmitter. We'll have to go back. It's okay. Let's see. Got a sneak peek of Barnes there. We'll go back to Barnes there in just a moment. We're gonna turn on our transmitter. Someone mentioned that microwave networks aren't working in recent versions, and to be perfectly honest, I haven't even tried. I haven't set up a microwave network or any sort of power relay network in a long time, as I generally just play in Sandbox and use, you know, like fusion reactors because they're light. I find that in the past when I set up microwave networks, I would just go nuts with it and have relays everywhere, and my computer would bog down and melt, and so I just found, you know, less processor load heavy ways of dealing with my power requirements. But microwave networks and power relay networks are super duper fun. And yeah, if they are working, I'm gonna see about maybe getting back into those. But for the time being, we'll just do a direct connection. And we're gonna turn on our transmitter. Again, it's just gonna pump out as much as we want there, because this thing's just gonna run full blast anyway. Who cares? It's just gonna send the power. Let's double check our instruments here. Yeah, we are sending 30 gigawatts on the far extreme UV spectrum, and let's actually point. Oops, I hit switch to instead of set as target, but that's okay. We should still have line of sight on one of these, probably this one. Activate receiver, and does appear we are, yep, there we go, 6 gigawatts of power. That is awesome. So 6 gigawatts gets to here. Doesn't seem too bad. Let's see if we can use it. Yes. Uh-oh, we are losing power. Don't know if this is actually going to work. the thing. Yeah, I didn't really put enough heat dissipation on this thing, so charging it might actually not be. I guess we'll see. Blasting it with 30 gigawatts of power, and we got about a gigawatt of heat dissipation. I don't know. I don't know what's going to happen here in a second. Let's open up our UI, make sure that we're going the correct speed. Uh-oh. Okay, 467 megawatts is what we have to maintain. We've got 912 at the moment. Now, I'm really curious what would happen in the real world if you were to activate a warp drive, you know, using beamed power. You know, you're sending basically photons that are traveling at the speed of light to a collector that then charges the drive, exotic matter, yada yada, and then it zips off into space, folding space and time around it, and suddenly is moving away from the transmitter faster than, or faster than the speed of light, right? So the photons feeding it are not able to travel faster than the speed of light. They only travel at the speed of light. So any photons sent after the warp drive were activated shouldn't ever be able to reach the receiver until it stops. And then much, much later, depending on how far away it got before it stopped. But that would probably be like a constant process, because like it would stop as soon as like it stopped getting photons, right? So it would stop immediately, and then the photons would catch up. So would it have to charge again and then take off again and go in like spurts or something? Like, how does it work? But we're also going to find out how it works here in KSP, because it appears that we are stable-ish at about 900 megawatts, so that's comforting. That's promising that this actually worked. Because I did not test this beforehand, so I have no idea what's going to happen. Now let's speed time up so that we can fully charge. Oh yeah. Oh, we are ready. We are ready. You guys ready? I'm ready. Here we go. In 3, and 2, and 1. Wait. I feel like I'm always doing this in the dark. Like, it's just always what happens. So what's the best way to see? Let's do it this way. Okay, 3, 2, 1, fire. And I forgot to turn off stability assist. Okay. And there we go. So we zoomed around in a circle. Kerbin's way back there. And we have... Oh, we're starting to get power back. Okay. So that's that receiver. Let's make sure we turn both of them on. Activate receiver. There we go. Now we're cooking. Okay. How far did we get? Hey, not bad. Not bad. Where's that going to put us? So we have ourselves a weird little orbit that kind of... That'd be an interesting communication satellite that was just instantly put in place. That's neat. Alright, let's try that again. Except... let's actually go light speed. Let's see, 81,000 kilometers above Kerbin. That's not bad. Got pretty far before the warp drive kicked out. Alright, let's see if we can do this again. See how far we can get. Alright, we are ready. And let's pick a target this time so we can point in a direction. Not a lot of options. Let's see. We should probably go this way. I feel like Kerbin's going to block us if we go that way, but whatever. Let's see what happens. Okay, ready? 3, 2, 1, and fire. And there we go. We are traveling at the speed of light away from a transmitter that is powering us using photons that are traveling at, you guessed it, the speed of light. But this is probably the simplest, easiest way to warp around, is put a power plant in orbit and then zip around with an ultralight. And this thing, you know, as long as it has connection, which it seems to have a pretty good connection, is going to do pretty well, all in all. I'll zip in here real quick. So it's nothing too fancy, I suppose. It's just the warp drive and then the receiver's bunch of batteries and capacitors to make sure that it doesn't lose power. So just a little extra capacitance in case of interruptions, and a little bit of attitude control provided by the warp drive itself. Other than that, there's an IHAL in there, right there, somewhere under that radiator, and that's about it. That's all it is. Let's see, where are we at? Oh, we missed Eve by a long shot because we were gabbing. I was gabbing. You guys weren't gabbing. It was just me. Let's see. Let's go to Jewel instead. Let's see if we can actually make a turn. Oh, look at that. It's a teeny tiny vessel that doesn't disintegrate when you turn at the speed of light. Although now it is a little shaky. Slow, easy. There we go. Okay. Now we are still getting about 2.5 gigawatts here. That's good. I suppose it helps that we have both receivers on. Oh, we lost power right there at that distance. Let's see if I can. Sorry about that, I gotta, there. IHAL says that we are at 31.5 gigameters from our hop. Link for relay is full, or not relay, I want power interface. I don't understand. Why did we drop out of warp? We have plenty of power. But, see, that's probably what you're going to encounter, is like maybe something passed in front of the transmitter momentarily, causing us to drop out of warp somewhere. So, a relay network is definitely optimal. Definitely comes with some issues when traveling at the speed of light and dependent on a power source that is traveling at the speed of light. Yeah, it gets super confusing. But that's, in a nutshell, something that you could possibly do with those objects. Let's see, I was also going to show, look how far out the, look how far out that guy is. Okay, black hole sun is not going to explode just yet. We're still producing power comfortably. And can do so for the next 30 years. Just beaming people around. I think it's pretty neat that this little part exists. It's not too horrible once you get used to it. You just got to get enough radiation and be used to the fact that you're going to need like a city block to cool it down. But what you get from it is super duper cool and worth it. Look at all those positrons. I have grams of positrons. And look, I can't even collect any more antimatter. It's unreal. And I have nothing on here that actually uses antimatter. once again, I just kind of store it because it produces it. If I were to turn this into an actual station in an actual campaign, there would be at least a docking port on here so that it could trade with something else. And finally on the list, did want to show you kind of what you can do between the two different types of the Bussard and the Daedalus engines in a little bit more detail. So this absurd looking little thing right here, really just wanted to do a proof of concept. When you have extreme amounts of warp power, total warp power is 21,000 tons. Warp to mass ratio is 146. When you have something like that going on, it only takes about 50 megawatts to get to warp. So you can put any old reactor on there that can produce not even close to that much, and you can be comfortable producing a warp-capable ship. Will this stay together in warp? No. I strut, and I strut, and I strut. I don't know if it's something with my graphics card or something, but my ships blow up if I don't use unbreakable joints. Don't know what to tell you. That is really the challenge, is producing a vessel capable of traveling through space at or greater than the speed of light without disintegrating on encountering the first dust particle. It's a challenge. So, first things first, 143.46 tons. Okay, 143,000 kilograms. I have 42,579 meters per second of delta V using a Daedalus engine fueled by fusion pellets, which, by the way, you make with liquid deuterium and liquid helium-3 that you can harvest from any old gas giant that has that in its atmosphere using a refrigerator unit, air scoops, that sort of thing. Super easy to refuel. Now, we're not really going to warp anywhere. I just wanted to show you on a vessel that's a little lighter than the Singularity station that we built earlier. This one, weighs like 100 tons less. You get a little more thruster at weight ratio. We're about 2 G's acceleration, which is pretty freaking sweet. We're producing 3,000 kilonewtons, and we are not even heating up that much. Remember that, like, when you're placing your radiators, you want to think about things like orientation to the sun for whatever reason, and you want to think about things like the total mass and like distribution of your vessel itself, because a little bit of piping and some weird stuff goes on. I don't know the exact maths behind it, but how you place your radiators on your vessel for whatever reason, well, actually it makes perfect sense to me, but like, I don't know how it works in the game. You know what I'm saying? It's important to place them in, spots that draw the heat away from the heat sources, I guess is the best way to put it. Sometimes I found that if I layer radiators and stuff like that in weird ways, they don't work as efficiently, and I can get away with using less if I don't stack them on top of each other. Who would have thunk? Anyway, we're just going to keep zooming this thing, because remember, we've got 41,000 meters per second left. We can go anywhere we want with this engine. Quite literally, anywhere. We can see what's up over here in the Dawn system. It might take us a little bit to get there, but we will eventually get there without using the warp drive. And then we can warp home. So you have a lot of options with this here Daedalus engine. It's super easy to use. Again, only takes about 100 megawatts of power to run it, and then it takes care of the rest itself. So you could do that if you're into that. It doesn't take that much as far as the graphene clover radiators, just 2 of them. And it starts cooling down pretty quickly. Got all this extra fusion material that I don't even need, but whatever. Now this is a little different, however, than the Bussard engine. The Bussard engine only produces about 1,000 kilonewtons of thrust, which is, a third the strength of the Daedalus, but the Bussard weighs 90 tons, where the Daedalus weighs like 70 or something like that. So that makes it a little different. Plus, it runs on hydrogen instead of fusion pellets, which, hydrogen is pretty light. But in Earthspect 113 is what we got out of here, as far as fuel and maintenance and power and that sort of thing. We got about 25,000 meters per second of delta V. Not quite, the same as the Daedalus. Same principle, though. You'd throw a refrigerator unit on here with some scoops, and you'd put it around an atmosphere containing, you guessed it, hydrogen, and you'd be able to refuel pretty simply, and then also be able to convert, from solid to liquid hydrogen, that sort of thing, using the refrigerator unit. Tri-alpha standard, it's what I like to use because I play in Sandbox. I actually did start a campaign mode recently because I wanted to go through the ranks again. I thought that would be super duper fun. So anyway, we've got 5.3 gigawatts out of this guy. We could probably turn this on and see if we can soak up. So radiator, beamed power. Yeah, probably not. No, let's just leave it as a radiator. We'll mess around with that other stuff later. So, if we were to activate our engine and burn us some solid hydrogen, we are producing 1,080 kilonewtons of thrust. It's a nice number. I like 1080. Heat dissipation, it's not really that much of an issue. I mean, it gets hot, obviously, but it's not actually going to get hotter than it can handle. It's got a little less than a G. I'm going to say it's like 0.85 around Kerbin. As far as acceleration, which, I mean, it'll get there. It'll get there. You can see that, this one's not really got as much going on for it as the Daedalus, but its fuel supply is extremely light. So you could stack a lot of fuel on this thing, a lot more hydrogen, just a lot. And it could go for a pretty freaking long time. And then, like I said, put a refrigerator unit on there, it'll go forever. Forever, So it's a neat little engine. Now, all of these engines, the Bussard, the Daedalus, and the Z-Pinch engine, which, as we mentioned earlier, the Z-Pinch has an advantage. It can be used in an atmosphere. These other engines cannot be used in an atmosphere. The Daedalus and the Bussard, also the Vista engine, that they won't do any good in an atmosphere. So the Z-Pinch has superiority in that field, in that it can do the double duty of lifting into orbit from an atmosphere and still continuing on efficiently in space as well. Whereas these guys are all space all the time, as you can see by the ginormous bulbous nozzle. It's a space nozzle. Big. Yeah. So that's how those things work. Now, if you were to just leave this thing on, maybe time accelerate. I am obviously pointing in the wrong direction with all of these launches, since I'm using cheating to get into space to make this video, because I don't have fancy editing software. I couldn't just do a bunch of launches and record clips of it. Just kind of have to show you all of this at once. Otherwise, I would have started accelerating on the other side so that we could go away from the planet. But I definitely hope that this helps at least somebody that wants to get off the ground with one of these realize, it's not so much like you need a lot of radiator. You just need efficient radiator. Make sure you got all your upgrades. Make sure you put them in the right spots. That sort of thing. And yeah, really don't have anything else to show you. I don't have any exciting explosions planned for this one. Maybe for my next one, stuff will blow up and things will be cool. But really, we were just doing some proof of concepts of how to get a few of these things running. And if you have any questions, feel free to ask, and I will do my best. Peace out.